Okay, so this is the lecture video for lesson C-4, which is titled Inscribed Angles. So we're talking about angles that are inside the circle, but they're a little bit different than the angles we've talked about before. Previously, we've talked about a central angle. Okay, a central angle looks as follows. We look at the top left corner of the video. A central angle was formed by the vertex of the angle was the center of the circle, and we had an angle such like that. Okay, now we'll talk about an inscribed angle, which looks a little bit different. It's not, the vertex isn't at the center, but the vertex will be at on the circle somewhere. Okay, a point on the circle. So an inscribed angle is an angle with its vertex on the circle and with two sides that are chords. Okay, so if you look at our example over here, we have our vertex B right here, which is on the circle, and then the two sides are chords because they have both their endpoints are on the circle. So every time we have an inscribed angle, we have something we call an intercepted arc, and this is the arc that lies between the endpoints of an inscribed angle. Okay, so our arc would be arc AC. There we go. So the measure of the inscribed angle is equal to half of the measure of the intercepted arc. So the measure of angle ABC in our example here would be 1/2 of the measure of arc AC. Okay, so let's use this stuff to answer some questions. First three. I'm going to find the measure of angle WXY. That's going to be half of the measure of the intercepted arc, which in this case is that 62-degree arc. So 62 over 2. That'll give us that the measure of our angle is equal to 31 degrees. So measure of angle WXY is equal to 31 degrees. Number 2. So this time we're given the angle. Well, let's get the arc. Okay, since we divided by 2, if we were given the arc to get the angle, we will multiply by 2 to get the arc. So the measure of arc DGF is equal to 2 times 113, which is 226 degrees. So that arc right here is 226 degrees. All right, number 3. Find the measure of angle JKL. So JKL is this angle right here. To be able to find that, we need to know its arc. So what we're going to do is we're going to subtract 360 minus those two arcs, because those three arcs together form the whole circle. So 360 minus 53 minus 65, that's going to give me 242 degrees. So this arc is 242 degrees. So the measure of angle JKL is just half of that 242, which comes out to 121 degrees. All right, intercepting a diameter. So if we have an inscribed angle that intercepts a diameter, meaning that the endpoints of the angle are the endpoints of a diameter, then the angle is a right angle, which means that the measure of angle BAC in this case would be 90 degrees. It's very, very, very useful, guys. So the measure of angle PQR here, PQR, okay, of course its endpoints are endpoints of a diameter, so it is a right angle. That one's finished. Now let's look at this one. This one's not exactly follows the thing, but it's still another good problem to do. Find the measure of arc BC, which is this right here. Okay. First thing I'm going to do is find the measure of arc AC by doing 2 times its inscribed angle. So 2 times 47 is going to equal 94. So this arc is 94 degrees. So then notice that we have a semicircle right here, meaning half a circle. So the measure of arc BC is just going to be 180 minus this 94. That's going to give me 86 degrees. Okay, moving on. So now we have what we call overlapping arcs, which says that if two inscribed angles intercept the same arc, then the angles are congruent. So notice that angle ABD and angle ACD, they both intercept arc AD. So because of this, we are going to say that they're congruent, or we'll say that their measures are equal. So the measure of angle ABD is equal to the measure of angle ACD. Okay, because they both intersect, they both intercept arc AD. All right, let's look at some problems here. Find the measure of angle RST. So RST and the measure of angle RUT. So notice that they both intercept arc RT. So find arc RT. And we can do that by doing 360 minus the other three arcs that we have here. So minus 64 minus 75 minus 139. Okay, and my calculator, that gives me that this arc is 82 degrees. So 82 degrees. Awesome. So then I can find the intercepted arcs, which are this, both of these will be this measure. That's going to be equal to 82 divided by 2. So those are both going to be equal to 41 degrees. And that's our answer. Now we add a little algebra to it. We know that ABD is 6x plus 26. And then ACD is 13x minus 9. They both intercept arc AD, so they are going to be congruent. So we set them equal to each other to find the x. So we'll do 13x minus 9 equals 6x plus 26. So subtract 6x from both sides, 7x, and then add 9 to both sides. You get 7x is equal to 35. So x is equal to 5. Okay, now to find the measure of arc AD, we're going to need to find either one of ABD or ACD. Okay, let's find ABD, I guess. 6 times 5 plus 26. That's 30 plus 26 equals 56. So double that will give me the measure of arc AD, which is what we're going to do now. So the measure of arc AD equals 2 times this 56, which is 112 degrees. So that's my answer. And that is overlapping arcs. Our last part on this first page will be inscribed quadrilaterals. What this means is that if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Meaning they add up to 180. So for a quadrilateral to be inscribed, it means that every vertex of that quadrilateral has to be on a point on the circle, okay, which is what we have right here. So we're talking about opposite angles being supplementary. So the measure of angle A plus the measure of angle C is equal to 180 degrees, because supplementary means 180. And then the other opposite angles would be B and D. Those add up to 180 as well. Okay. So what we'll do is we'll use this to answer some questions. All right, so let's look at number 8. It says find the angle measures below. I'm given two of these angles. I'm given angle M and angle L. I know that M and K are opposite. This is a quadrilateral. It's inscribed. So M and K are opposite angles that are supplementary, as well as the same thing with J and K, J and L. So the measure of angle J will just be 180 minus whatever the measure of angle L is. Same thing with define K. We'll do 180 minus 45 this time. This will give me 135. So this is honestly the best way to do these is through supplementary and all like that. Okay, so that's it for that one. Okay, now let's move on to the next one. Number 9 says find each angle here. Okay, we got it. So let's move on to the next. Number 9, find the measure of each angle. Okay, this one's a little bit more difficult, but not too bad, I promise. So what I want to do is I want you to notice that each of these angles are inscribed angles in this quadrilateral. Like angle A, angle B, angle C, and angle D are all inscribed quadrilateral angles. So angle A is going to have an inscribed angle. It's an inscribed angle with an intercepted arc of from B to D over here, opposite it, right? Sorry. So its arc would be 61 plus 47, which is 208. So to find the measure of angle A, you're going to take half of that 208, which is going to be just 104. Okay, so we'll do that similarly for all the rest of them. Okay, now let's find angle. So let's see. To do angle B, we're going to need this arc right here. So we can do that by doing 360 minus all the other arcs. Okay, and that's going to give me, so 360 minus 39 minus 61 minus 147. That's 113. So this arc right here is 113. Now to do angle B, it's going to be this 113. It's from A to C. So 113 plus 147. Then you're going to take that and you're going to divide by 2. So together these give me 260. Okay, 260 divided by 2 is going to give me my angle measure right here, which is 130 degrees. Okay, similarly for C, you'll take 39 plus 113, because that's the inscribed angle there, or intercepted arc. 113 plus 39 is 152. And that's divided by 2 will be 76 for angle C. And then angle D, 39 plus 61 is 100 divided by 2, so this is 50. Okay, that's one way to do it. You could have also found two of them, and then you could have done their opposite angles and found the supplementary from that. But either one works. All right, that is the first page. Let's go to the back to go to number 10. We got a bunch of algebra problems back here, and that's what we're going to be doing for these. So number 10, we have an inscribed angle, obviously, and we're given the arc measure to be 158. So just remember, we know that the angle measure, inscribed angle measure, is half this intercepted arc. So I'm going to set up my equation to solve for x as so. The angle, which is 8x minus 9, is equal to half of the inscribed arc, so 158 over 2. So we'll just solve for x now. 8x minus 9 is equal to, so 158 divided by 2 is 79. Okay, add 9 to both sides. 8x is equal to 88, so x is equal to 11. And that's our answer. Number 11. This time notice that our angle we have here is WXY. It intercepts a diameter, so that I know that the angle is 90 degrees. So I can set the expression for the angle equal to 90. So solving for my answer, my equation, very simple equation here. We know that x is going to be equal to 7. Number 12. All right, this one's a tad bit harder, but not too much. What my plan is here, I am going to, let's see, I am going to find, yeah, that's what I'm going to do, okay? What do I want to do? All right, so what I'm going to do is I know that from here to here is this arc right here that I just drew is the intercepted arc of this angle right here. So we know it has a measure of 114 times 2, okay? So 114 times 2 gives me 228. Okay, that's that whole angle arc. Now I can find this little bitty arc XY, because my plan is it's the intercepted arc of this angle W right here. This is what we have. So if I take half of that, that'll be equal to the 7x plus 6. So that's my plan. So we do 360 minus 78 minus 228. You get that arc is equal to 54 degrees, I believe. Yep, 54 degrees. So we'll set this angle, which is has expression 7x plus 6 equal to half of the 54, which is 27. Subtract 6 from both sides. Okay, and then you divide both sides by 7, so x is equal to 3. Awesome. Number 13, excuse me, sorry. Now this one, we're going to find the arc AC right here by doing 360 minus 92 minus 162 to get that the arc measure is 106 degrees. Okay, now we know that the angle is equal to half of that arc. So it's equal to 53. Now we just solve this like a regular algebra problem. To get that x is equal to 9. Hardest part with these problems is just setting them up, okay? Alright, number 14, find x. So here's what my plan is, okay? This arc measure is on some arc that doesn't have anything. So what I'm planning on doing is finding this arc measure and then adding all three of them up to 360. Okay. So, or actually what I'm going to do is just find this, and then we'll find what this arc measure actually is and set them equal to each other. So first thing I need to do is multiply this angle, inscribed angle, by 2 because to get the arc measure, which is 134. So we'll do 360 now minus 120 minus 134. Okay. So 360 minus 120 minus 134. That's 106. So I know that 5x plus 21 is going to equal to 106. Okay, that's my arc measure. So we'll subtract 21 from both sides. That'll give me 5x equal to 85. So x is equal to 17. That's all I wanted to find was x. All right, number 15. So notice I have an inscribed quadrilateral right here, and then I'm given stuff for the a pair of opposite angles. We know that in an inscribed quadrilateral, opposite angles are supplementary, so we'll set this up as follows. We'll just add those two up. Set them equal to 180. Okay, that's what supplementary means. So that gives me 9x plus 63 equals 180. We'll subtract 63 from both sides to get the 9x is equal to 117, which gives me that x is equal to 13. Okay, that's number 15. Moving on. Find x here. All right. Here's my plan here. I'm going to find angle in first. I can find this because it is an inscribed angle for this arc that contains 91 and 135. So we'll add up 91 and 135. And that gives me 226 degrees. So then we'll say 200, we'll find this angle divided by 2. That gives me 113 degrees right here. Okay, so this 15x minus 23 and this 113 add up to 180 because they're supplementary, because they're opposite angles of an inscribed quadrilateral. So 15x minus 23 plus 113 equals 180. Okay, now let's solve for x. So simplifying what we have, we've got 15x plus 90 is equal to 180. Subtract 90, 15x is equal to 90. Dividing both sides by 15, you get x is equal to 6. Not 12. Like it has in my notes, excuse me. Alright, that's 16. Number 17. I got another quadrilateral here. Okay, my plan is to find angle H because it's going to be half of this arc right here. So 50 plus 96 gives me, let's see, 146. Then you divide that by 2, that's 73 degrees. So my equation will be 12x minus 25 plus the 73 degree angle equals 180. So 12x, 73 minus 25 is 48. $12x is equal to 132. Divide both sides by 12. X is equal to 11. And voila. Number 18. If the measure of angle KJL, so KJL is 3x plus 2, and the measure angle KLJ is 7x minus 32, find the measure angle arc KL. So I notice, I'm looking at this angle JKL right here. It intercepts the diameter, doesn't it? So that tells me that is 90. So now I can add all three. We know I've got something for all three angles in my triangle here. I can add them up to 180. So, or similarly, just add those two up to 90 because 180 minus 90 equals 90. So 3x plus 2 plus 7x minus 32 equals 90. So 10x minus 30 is equal to 90. 10x is equal to 120. So x is equal to 12. But that's not what we're looking for. We're looking for the measure of arc KL, which will be 2 times whatever this angle is. 36 plus 2 is 38 degrees. So KL will be, so measure of arc KL is 2 times this 38, which will be whatever that is, it's 76 degrees. Okay, we have 2 more problems. This one's a really good one to do right here. Number 19, in circle O shown, let BE be perpendicular to IS. Okay, that's what I got right there. That's the right angle. And the measure angle TOE is 36 degrees. Okay, this is a central angle. So I know that its arc, intercepted arc, i.e. TE, arc TE will be the same measure. That's part A. Okay, so I'm going to fill in as much as I can right now. I know this arc from S to T is going to be 54, and the reason for that is because it's this whole thing from S to E would be 90, so 90 minus 36 is 54. This is the 90-degree arc. This is a 90-degree arc. This is a 90-degree arc. Okay, now let's look at some angles and stuff. I have an inscribed angle TBE right here. That's going to be half of this 36-degree angle, so that is 18 degrees. Let's just start going on the list now. SIT, okay? SIT is right here. It's an inscribed angle, so it's half of its inscribed arc, which is 54. So this will be 27 degrees. 54 divided by 2 is 27 degrees. The measure angle BIS will be half of the, it's an inscribed angle, so it's half of the 90-degree arc right there, so it's 45 degrees. Measure of arc IT now. IT, okay, so it's from I to T, so it's this, we have a 90-degree angle plus a 36, so it's 126 degrees. Measure of arc ST, we've already found that to be 54 degrees. SB, already found that to be 90. IOT, angle IOT, so IOT, this is a central angle, okay, with its intercepted arc IT, which we found to be 126. Central angles have the same measure of their intercepted arc, so this will be 126 as well. And then TBI, all right, we already found TBE. Now let's look at EBI right here, or let's just look at TBI. TBI intercepts this arc right here, which is 90 plus 36, which is of course 126. You divide that by 2, and that'll give you your angle measure, which is 63 degrees. And that's it for that one. Okay, number 20, our last problem. If a polygon is inscribed in a circle, then each of its vertices lie on the circle. Which of the following correctly depict an inscribed polygon? The only one with all the vertices on the circle is A. And with that, we finish lesson C-4, which is inscribed angles. This video was recorded a little bit after the homework was due, but if you have any questions on anything about this as you're studying for your test on circles, please let me know. Don't be afraid to send me an email. Thanks for watching.